Alright, hello everyone. So we're back for the next video in our Python Pygame game programming series for kids. Today I think we're going to start work on adding in an enemy in our game that will just sort of move around the screen. Now to start, I'm going to start from just this version of our game where we have our player here indicated by the white square that I'm moving around with the arrow keys on the keyboard, and then this collectible, which is in red, which I can collect, and then a random one will be generated somewhere else on the screen. Now, if you've done some of the later exercises that fix the collectible so that it appears 100% on screen, or that it has random sizes and colors, that's fine too. I'm just going to sort of start with this sort of base here. It won't be too different. Alright, so to start, we have our big Pygame program here right now. Our program's starting to get a little bit complex, and in order to illustrate what I want to show you all through this exercise, it's going to be a little bit hard to do it within the context of this program. So what I'm going to do actually is create a separate program that will let us test out getting our enemy movement stuff working, and then later we'll come back and integrate it into our actual game here. So to do that, I'm going to create a new file, which will, create this new thing over here. I'm going to switch back to my actual game here, and then select everything, copy all of that code, switch over to our new file here. I'm going to go back to the old one and close it since we're done with that for now. And I'm going to save this, and I'm going to call this Pygame 4.0 Standalone Enemy Movement. Since we're going to just have the basic enemy movement stuff in here without other things. Now, so what I want to do to reduce the complexity that I'm dealing with to start now is I'm going to go through and remove all the code that's not going to be important for our enemy stuff here. So if I read through things here, creating the screen is going to be required. We don't need anything about the player or the collectible, so I'm going to delete that. We don't need to handle player input, so I'll delete that. I don't need anything about the player or collectible, so I will delete all of that code. And then I still gonna need the part that clears the screen to a background color. But then I don't need to draw the player or collectible since they don't exist. So if I start with that, and I guess I'll go ahead and move this to a separate line so you can see the full thing. But now if I run this basic program now, assuming everything's working correctly, I should just get this black screen for my game window, and then I should be able to close it. And that works fine. Alright, so to add an enemy, we're going to need to draw it somewhere on the screen. So actually I'm going to open up our original program here. So if you recall how we actually can draw things on screen, we need to have a position like with the player here. It's defined by the X and Y coordinates. And then we're going to need to have a rectangle defined for what we're going to do here, and then we're going to actually need to draw our object that we're going to be drawing. So I'm going to go up here and start working on that for the enemy. And actually, I'll sort of bring this code over to the side a little bit so that you can see roughly what I'm doing. So I'm going to define the enemy's position. It's going to have enemy X. We'll put it at 200 again. You can put it wherever you want. Enemy Y. So that's the enemy's position. Now what else do I need to do? I'm going to need to create a rectangle for the enemy. So I'm going to go here and just do define the rectangle for the enemy. So I'm going to want my enemy rectangle be pygame.rect to create a new rectangle. I'm going to take the left position, which we're using enemy X, enemy Y. Now I'm going to need a size for the enemy, so I'm just going to change that to enemy size and pixels. Enemy size and pixels. Now, I just started using this name here without defining it or saying that it exists in my Python program, so I need to actually go and define it to make sure it exists. I'm just going to choose 20 again, sort of arbitrarily. So that's it for our enemy so far. We're not doing anything yet, but I'm just going to run the program again to make sure nothing's crashing. It's still working. That's good. Alright. So after that I need to draw our enemy, which is done with this pygame.draw.rect call, and I'm going to need to define a color for that as well. Don't know if you can quite see that, so I'll increase that so my head's not in the way. Alright. Draw the enemy. Okay. I'm going to need a color for the enemy. Color. I used white for the player here and green for the collectible in the original program, so I'll use blue. So I'm going to have 0 red in my color, 0 green, but 100% blue, the maximum blue value I can have for the enemy. Alright, and then I need to draw my enemy. So I'm going to draw it to our screen, our surface we created. I'm going to use the enemy color and the enemy rectangle. Alright. So if I go and run our game now, we should see a blue rectangle kind of in the center. It doesn't do anything. That's fine. And good. Alright, so now what we want to do is we want to have our enemy start to move without us doing anything. We want it to move sort of on its own, like it's a living creature within our game. So if we go back and look at our original code here, what you'll notice is for how we moved our player based on keyboard input, we always like increased or decreased the player's position by some amount. And that was in response to keys being pressed down on the keyboard. Now if we want our enemy to move sort of on its own, we don't want this to only happen based on keyboard presses. We kind of are going to want it to happen on its own. Now, so if you look at our game here, you'll notice we have this loop here, which runs basically as fast as our program can execute right now. And so if we want to have our enemy sort of move on its own, we should be able to just somewhere in this loop, we want this to happen even if there aren't any events, so we do not want it as part of this for loop. But we do want it to happen within this while loop, so I want to make sure I have things indented right here. And now so what I want to do is move the enemy. I'm going to define a constant for how much I want the enemy to move, and I'm going to set it to 1 for now to test something out, and we'll see if I can show you what I expect to happen or not. Now, if I want to move my enemy, I can take my enemy's X position. We'll start by moving it horizontally to start, and I'll have it move to the right. So I'll add the enemy movement amount in pixels to my enemy's X position, and then so that means every time we go through this loop, it's going to move the enemy to the right a little bit. This enemy X position gets taken into account when we define our enemy's rectangle here. You see that right here. And this rectangle is the basis for what we ultimately draw for the enemy. And so that's going to reflect what's shown on screen. So now let's try running it and see what happens here. Okay, so you saw how it moved really, really quickly off the screen. You might not have, but let's try this again and see if you can see it. So it's basically instantaneous. So why is that? So our game is basically running as fast as it can through this loop right now. There's no pausing or waiting. And so how fast our enemy moves is actually going to somewhat depend on how fast the computer we're running our program on is. If our program is running on a really old or slow computer, or we have lots of other programs running at the same time, it might run really, really slowly. If our game's running on a fast computer, like kind of what I'm running this on now, the enemy will move super quickly. Now just to see if I can get it to move more slowly, I'm going to change this temporarily to a very small sort of decimal value. And we'll see if we can see the enemy move a little more slowly. It might not affect much. Oh. Haha, that's... I can't even tell if it's moving. Anyway, my guess is that Pygame with the rectangle stuff here, it can't handle sort of fractional floating point or decimal values, so we have to have whole numbers. Anyway, so something I want to show also before we try and fix this problem is I'm going to open up Task Manager on Windows to show you, let's see here, our Python game should start with P here. So this is our game running right here, and you'll notice it's using like 23% of the processor, the CPU in my computer right now. We'll observe and see if that changes after we make some fixes. So how do we slow this loop down, how fast our game is running, to make sure that we have a consistent speed that we can control on just about any computer that our game is running on? Well, Pygame has some functionality built in for this. But basically what we want to do is have our game execute code each iteration of this loop, and then if we have sort of, and we want this loop, one iteration to take some fixed amount of time for the most part. And therefore we want this code to execute, and then if there's more time left before you reach that fixed amount of time, then we'll want to essentially wait some. So for example, if we wanted this loop to take a whole minute, a whole 60 seconds to execute, we'd want to do something kind of a little bit like this. Execute our loop and then wait for 60 seconds or something like that. It's not quite what we're going to do here because that's not the way we write code in Python or Pygame, but that's the basic idea. What do we want to do here? Well, Pygame, I believe, has something built in to the time module in it. And so what we want to do is the simplest thing to do is use use this clock class, and so this will help us sort of track time. So how can we do this? Use this in our game? So first off, we're going to need to create a clock object, and because we want this to track time over multiple iterations of this loop, we're going to need to create it before the loop so that it doesn't keep getting reset and losing what it's tracked so far every time we go through the loop. So to do that, I'm going to create a clock here, pygame.time.clock. As you can see there, that'll create a clock that we can use in our program here. So there are a few different methods on this clock class, and so let's read up on the tick method here. So this says that this method should be called once per frame, also like once iteration of this loop. It will compute how many milliseconds have passed since the previous call. So if I want to compute that here, I can do clock.tick, and that will return us a numeric value that is the time elapsed since last frame in milliseconds, ms. I'm using that as just an abbreviation since this variable name's getting a little bit long. So that will get us the elapsed time, but we have to actually use that in our program to make it have an effect. So, well, let's just do a little print statement. Time elapsed since last frame in milliseconds. So if I run our game now, well, you can't really read it, but if I click on the window to pause it, you can see that it's taking somewhere typically, I think, between like 4 and 12 milliseconds to execute our game loop, which is fairly fast because we don't have a lot going on. But you'll notice here, if you read the documentation for this tick method, what it says is if you pass the optional frame rate argument to the function, it will delay the game, do that waiting that I talked about earlier, to keep the game running slower than the given amount of frames per second that you give it. So what I want to show here, so let's talk about frame rates a little bit, also known as frames per second, what's going on here. So with games or movies or TV shows, any type of animation, all you're really doing is showing like one picture after the other. And what this does, if you do it fast enough, creates the illusion of movement. And movies and TV shows typically have a little bit of a lower frame rate overall compared to games. Games typically try to target executing at least 30 frames per second, although a lot of games now target even like 60 or higher number of frames per second. That means like this loop would execute 60 times in 1 second. Now, you generally want to try to have a consistent frame rate through your game to make the movement appear smooth and not like jittery and jarry from the amount of time how you're switching the different sort of drawings that you're displaying on screen changing frequently. Although there are solutions nowadays to sort of adapt that. But so we're just going to target a fixed or constant frame rate. And at least for now, we're going to try to aim for like 60 frames per second because that's what a lot of modern games target. Although if we end up finding it, we need to run things more slowly at 30 frames per second. We'll change that later. So I'm going to define a constant for our frames per second here, which we're going to target 60, and then I need to use that in clock.tick frames per second here. Let me increase that a little bit. So I'm going to create a comment here to sort of briefly summarize what we're doing here with this clock. Update the game clock. And what this will do, this will pause our game loop temporarily to try and hit the target frame rate. So that's roughly what's going on now. So let's run our game and see what's happening now. So first off, I hope you could see, let me run the game again. Actually, I'll change the enemy's starting X position to be 0 so you can see a little bit more. So first off, you'll notice that our enemy is moving a little more slowly across the screen. That's sort of because we have a lower frame rate. You can see it's now taking about 17 seconds or 17 milliseconds to execute one of our frames now because of this clock tick call. If it's taking less than 17, that's just waiting until it basically hits 17 to continue executing our frame. So that's good. The other thing I want to try and notice here is if you look at our Python game now, you'll see it's using only about 6-7% of the CPU, the processor on this computer now. That's basically because we're having these sleeps going on. And in a lot of programs, it can be useful to have sort of this sort of sleeping logic because depending on how things are set up, if you're executing too much code using too much of the CPU at once, then you could theoretically like overheat your CPU and melt it and ruin your computer. This wasn't really too concerning with our like 23% CPU usage earlier, but it could be concerning later. Anyway, so let's stop our game now. So we have our enemy moving some fixed amount per frame here. And that's good now that we have sort of a stable movement amount. But it's hard to sort of change our game and feel like we have control over exactly how quick our enemy is moving, because the movement is based on how quickly our frames are executing in our while loop here. So what would be good to do is if we could change the movement amount to be based on things that we understand kind of in the real world here. Like if you hear in cars, you'll think about like miles per hour. That's expressing some unit of distance that we move in a given amount of time. What I'm going to do here is do something similar for our enemy, but change it to be the enemy movement amount in pixels to be per second. And I'm going to use seconds because seconds are typically easier for us as humans to understand and reason about than milliseconds, which is what our clock is doing here. Now, in order to make this work, I still am going to need to sort of compute the enemy movement amount in pixels each frame. And because this is going to change based on how much time our clock has ticked, I'm using lowercase letters here to indicate this isn't a constant. This is something I expect to change. And then I'll set that to 0 for now just to update this code. So in order to calculate the enemy movement amount in pixels, we want to take the enemy movement amount in pixels per second and then multiply that by the time elapsed since last frame in seconds. And let me sort of wrap this around to multiple lines here so that you can see what's going on with my slightly larger font on this screen. If you haven't seen this before, you don't necessarily need to worry about it too much now, but as you get into, potentially like later middle school or high school classes, this will become important with like math and science type of calculations. So what we have here is a movement amount in pixels per second. So we have, let's say, I don't know, 10 pixels per second. Well, you can think of this mathematically as I'll use double equals since we're programming, is that's 10 pixels divided by 1 second. Or you can think of it a little bit as 10 pixels well, I guess I'll use underlining here. Divided by 1 second here. And so that's how fast our enemy is moving here, right? But what we want to do is our enemy X position is in units of pixels, and so if this is our enemy movement amount in pixels per second, or the rate of movement here, what we need to do is calculate the enemy movement amount, which is just going to be in pixels. So we need to take a number like this here and convert it to just pixels. So how do we do that? So this goes by different names depending on what you're thinking of, but sometimes it's called like dimensional analysis or something like that. But this is sort of a simple math thing. So if we go here and we take our rate of movement here, and you want to multiply it here by something that will give us some number of pixels, right? So what we can do here is multiply this by some number of seconds, and what will happen is the sort of seconds here will cancel out. So let's say our game took, I don't know, 30 seconds. We want to move our enemy based on 30 seconds of time that elapsed here, right? So if we do that, 10 pixels times 30 seconds, which we'll go through shortly, what happens here is, like, the seconds here, they end up canceling each other out here, right? So you end up with 10 over 1, which is just 10, and then you have 10 times 30, which, if we get rid of this, will end up being 30, which will be 10 times 30, which equals 300 pixels, right? And so that's sort of the basic idea of how we can kind of compute this movement for our enemy here. So if I go back to our game here, we have the elapsed time in milliseconds, but what I want to do is use the elapsed time in seconds, because that's what we've defined the rate of our enemy movement as. So if I go and do that here, then what I need to do is convert milliseconds to seconds. And so how do we do that? Well, we used sort of the same principle here that we were using. So in 1 second, there are 1,000 milliseconds. Milli means seconds. Means 1,000. All right, so if we have that, and then we have our existing elapsed time in milliseconds, which, if you'll recall, is 17 based on what we get back from clock.tick typically. That'll give us our result. Now, I don't know what 17 divided by 1,000 is off the top of my head, although I guess it's just simple of moving the decimal place some. So I'm picking up the calculator, and as you can see, it's 0.017 seconds here, because the milliseconds here will cancel out. And you can see that by the decimal point here has moved essentially 1, 2, 3, based on the fact that we have 1, 2, 3 zeros here. And again, the milliseconds basically cancel out here. So a little bit of math there for you. Alright, so to do this conversion, we can do something very similar. So I'm going to define a constant for the milliseconds that are in 1 second, and that's 1,000, right? So then if we take our time elapsed since last frame in milliseconds here, I'm just going to go ahead and maximize this temporarily for this typing. And then if we multiply that by the milliseconds per second, Although actually what we want to do here is divide. So if we go back to our diagram, we see the 1,000 is, oops, at the bottom here, which equivalently, if we were to write this out, this would be 17 over 1,000, right? Because the 1 doesn't do anything. So back to our game. So if that's kind of the movement amount here, that should calculate the time elapsed in seconds. And update our print statement here. Actually, I'll add a second one just so you can see the difference. And then run our program, and we'll see what happens. So you can see here how it's printing out the milliseconds, the 17, and then the time elapsed in seconds on the next line, which is exactly what we just calculated. Now if we go back to our game, you can see the enemy is moving very slowly. It's moving basically 1 pixel every second. And so you might have noticed, like if I hold on the title bar here to wait a really long time, something like that, you should be able to see our enemy move pretty quick, or jump a lot there. So if I hold it down again, we should see it move a lot more quickly. 1, 2, 3, peep. And that's just because we're taking into the account the elapsed time here. So let's say we want to make our enemy move at, I don't know, 30 pixels per second. Let's just see how fast that is. So you can see now the enemy's moving much more quickly. I'm going to go ahead and bump that up to, I don't know, 60 pixels per second or something. So that's a little bit faster. You can bump it up to be really fast if you want to, but as you can see, oops, now our enemy will eventually go off screen. So how can we correct that? Well, if we go back to Paint, and I'm going to, I'll save this real quick. Oops. It's Pygame. I'll name this Unit Conversions. Alright. So if you'll recall, our game screen is basically this big box here. It has coordinates of 0x, 0y at the top, and then the bottom right, it has our screen width in pixels, -1 is the x, because since we start at 0, we have to subtract 1 to account for that. And then screen height in pixels, -1 is the y coordinate there. And then in the top right, we go all the way to the right here, but our y is still 0, because if you recall, y increases going down here. And then here we have 0 for the x in the bottom left corner, but the y is sort of the maximum value there. So those are our 4 corners that establish our coordinate system for our screen here. And so the problem we have here is that our enemy, he's moving always to the right, right? And so eventually he'll exceed the maximum pixel, our screen width in pixels right here. And so if that happens, he'll go off screen and he won't be useful anymore. So we want to try and keep him on screen. And so how can we do that? Well, what we kind of want to have happen is we can make him sort of bounce back. So if he goes here all the way to the right, and then he hits sort of the edge of our screen, what we'd want to do then is have him sort of bounce back and go the opposite direction there, right? So how can we do that? Well, thankfully, this is fairly simple. We just need to kind of negate whether we're sort of adding or subtracting the adding or subtracting this movement amount from our enemy's position, his X position here. So this actually brings up an interesting point. So there are two concepts related to this that we want to cover. Speed, which is sort of the absolute value or positive rate of movement. But there's a related concept called velocity, which is sort of a directional rate of movement. It can be positive or negative here. And so what we really have right now is the speed of our enemy here. But what we need to do is make it a velocity that can sort of change depending on whether hit the edge of the screen or not. So I'm going to need to sort of change this speed into a velocity, and sort of for simplicity's sake, we're going to need to modify this. So I'm going to make this variable name lowercase to reflect that I'm allowing it to be modified now. So I'm going to go update that, and let's run our game just to make sure it's still working properly and nothing's broken. Okay, good. I'm actually going to bump this up to 100 just to be able to show this a little bit more quickly. So, pew! So he's still going off screen, that's fine. So what we need to do here is, well, what we want to have happen is if the player, or if the enemy moves off of one of the edges of the screen, have the enemy bounce back in the opposite direction. That's what we want to do. I'm typing that out as a comment to make it clear, to communicate the intent of what I want to do before I worry about exactly how we write code to do that. So we have our enemy speed in pixels per second, and as I mentioned, we're going to want to make that change into a velocity so that it can have a direction. Now, because we're going to need to potentially change this depending on whether the enemy sort of goes off the screen or not, we're going to need to check to see if the enemy has moved off, say, the right side of the screen. So we'll do that first. So we want to check for enemy moved off right side of screen and create a Boolean variable, something that'll have a true or false value that we can check for in an if statement. And so how do we check for this? Well, we can check to see if our enemy X is greater than or equal to, well, we'll just use screen width in pixels here for now. We'll just use greater than for simplicity, even though it won't be 100% accurate. It'll be close enough for this demonstration. And we can improve this later. So then if we want to act upon if the enemy actually moved off the right side of the screen. We will want to flip the velocity here by multiplying it by -1. That'll change it. If it's going 100 pixels to the right, now we'll go back 100 pixels to the left for our movement. So let's run our program, make sure that's working correctly. Boop. Oh, haha, you see, so it's not quite working correctly. Why is that? Well, that is because our enemy movement velocity is always being reset to 100 within this loop every time here. So I'm going to basically cut that line with Control X and move it up here, sort of to where we're defining our enemy's thing. So I'll change this comment to make it more accurate, so we can put all of our enemy related code and parameters up here. So now if I run our game, I should expect it to work a little bit better now. Oh, so now you see he's moving back to the left. And, oh, now he's moved off the left side of the screen here. So how can we check for that? Well, if you recall, the left side is 0, 0 here, so we can do a similar check for enemy moved off left side of screen. The enemy X is less than 0, which is our minimum pixel coordinate. Oops, I made a typo here. Of screen. Then we can just sort of reflect our velocity again. Right, so now let's run our game and see if this works correctly. Boop. Hit right. Boop. Oh. I made a typo somewhere, it looks like. Ah, I forgot in here for my units. Let's run again, and hopefully this will work now. Boop. Boop. So you see now it's basically bouncing back and forth, which is good. I'm going to remove these print statements for the time, elapsed time, and just sort of print out the velocity here so you can see what's going on as this movement occurs. So now you see it's 100. Nope, now it's -100. Now it's back to 100. So that's kind of fun. There's one thing I want to do here, which you'll notice that the bodies of these two if statements have the same action going on, and at least for now I think we'll want that to be the same. And so what I would kind of want to do is reduce sort of the duplicated code here to reduce the amount of code that I need to understand and read. And so how can we do that? Well, essentially we kind of want to combine all of this under one condition. So if I select this code here by going to the end of the line, pressing Shift Home, and then Control X on my keyboard, I'll go up, press Enter, Control V to paste it. So now I'm checking for both of these two conditions here. And if I want to check if it moved off the left or right side of the screen, I can do something like this. Create a Boolean variable where I check to see if enemy moved off left side of screen, or the enemy moved off right side of the screen. That way, that's this compound condition here. And to make this order a little more consistent, I'll move the left to be first. So now if we use this new condition right here, then we can update our enemy movement, and then we don't need this sort of duplicate line right here, so I'll delete that. Alright, so let's run our game now here. Boop. Boop. Okay, everything's still working fine, so that's good. So our player, or our enemy, is now moving left and right and bouncing back and forth horizontally. But now we want to have him move a little bit vertically as well. So I would recommend, if you are watching this video, that you sort of pause now and actually try and implement this yourself. I think I'll stop the video now and move that to a separate video where we'll cover that.